take a look at current, potential difference, and resistance for GCSE Physics. Now these three keywords, they're like the bare minimum that you have to know for circuits and electricity topic in your GCSE exams. And this, if you don't like sometimes you might have to memorize some things, but I just want you guys to just don't memorize, never memorize at least these three keywords, because they're the absolute fundamentals. And at least I hope that I can teach it to you guys in a way that will help you understand the reasoning behind it. And to help with that, I'll use a bit of an analogy in order to help further, help to understand the basics, essentially. Current, potential difference, and resistance. So, current has the symbol I. Potential difference has the symbol V. And resistance has the symbol ohms. And I'll explain what each of these mean in just a second. So these are all for our circuits, right? Our circuits is basically just, you have a battery. Let me just draw that again. And it's powering up a circuit. This circle with a cross is the bulb. Now it's the flow of electrons, right? Remember, electrons flow from the negative to the positive, but we currently use something called the conventional circuit. Conventional circuit. And this circuit was developed before it was discovered that electrons flow from negative to positive. So our conventional circuit is actually positive to negative. So we have our positive terminal. The long dash is always the positive. So this is the battery, by the way. Starts from the positive, and these electrons, they're going to flow from the positive to the negative terminal. Like so. We can imagine this with a bit of a water pipe. Say we have a bit of a water pipe, and we're going to try to send it up here into our house, right? To move it upstream, you're going to need something to push it up, right? You're going to need something like a generator powering it up. This is like the battery. So it's pushing the water, in this case the electrons, up and around the circuit. The resistance is like the stuff blocking it. Like you might have some sewers in the, some sewage or some debris within the water, what do you call this? Water sewage or the pipe. You might have some debris or blockage blocking it, restricting the flow of water. That's called the resistance. Potential difference, by the way, is the power driving the force. So that's going to be the battery. The current is just the speed of, or like the measure of the flow of electrons around the circuit. So it's the flow of the water within the pipe in this case. So let me try to explain this in a bit of a more simpler way. We have current. Let's start with current, right? Current is measured with the unit amps. Unit amps. And it has the symbol A. Current has the symbol I, by the way. Now, this was what really confused me. Why are there two different things for essentially the same thing? Well, this current is called the quantity. Now, this is going to get really confusing. I'll try to explain it in the most simple way possible. The unit is called the SI unit. All right? So the current is the quantity, and the unit is the SI unit. By this, I mean, so basically, current is, so imagine you have the pipe with water flowing through, right? If you switch the current with electrons, you've got the current. It's just the word used to describe these movement of electrons. That's the current, the movement of the flow of these electrons around the circuit. The SI unit, the amps, the amperes in full, the amps with the symbol A, symbol I for current, by the way, the symbol A for amps, that's just the unit to measure this flow. It's a unit of measurement to measure this flow of these electrons. So for example, if we have something called mass is just the idea of the weight of something, right? The SI unit for mass is kilograms or grams, whatever. It's just the unit used to measure your quantity. Just give another example. Say we have, what else could we have? We could have speed, right? Speed of something. The speed is the quantity. It's the idea of how fast something is moving. But you don't measure something with the unit speed. You need something to measure the speed, right? So the unit for speed is going to be like, say, kilometers per hour, or more commonly, meters per second. Another one, time. How long it takes for something to happen. You don't measure time using time, right? Use seconds or hours, right? This is the SI unit. It's what you use to measure your time. One last final example. We could have, say, the length of something, right? The length is the quantity. It's the length, the height of something, for example. But you don't measure something with length. You use units like centimeters or meters or even feet if you're American. That's going to be the SI unit, the unit of measurement. So the current is just the flow of electrons. But you don't measure the flow of electrons, the current, using current. You need a unit, the SI unit, called amps, which is the measurement of the flow of these electrons. Let's take a look at potential difference. Potential difference is even easier than current. It's just what powers the movement of these electrons. If we have our water pipe example again, it's going to be the generator, the battery. In circuits, it's the battery that's powering the movement of these electrons, right? And it's measured with the SI unit voltage, also known as volts. So if you have 50 volts, that's the power driving the force of these electrons. You might see that 50 volts in your, say, your laptop. It's going to be 50 volts multiplied by the amperes to get the wattage. Remember amps? Amps is just the measure flow of electrons, right? And current is the energy that's pushing it. So if you multiply the two together, you're going to get your wattage. Anyways, your voltage, also known as volts, is the SI unit for potential difference. Symbol V. Potential difference, surprisingly, also has the symbol V. And that's just the battery pushing the electrons, or the pump pushing the water along the pipe. And lastly, we've got something called the resistance. Resistance has the symbol R, and it's measured with the SI unit. So the unit of measurement for resistance is ohms, spelled OHMS, like so. That's going to be the SI unit, right? It's basically what the word suggests, resistance. It's the resistance on the pipe pushing the electrons. It's what's blocking it, slowing it down, making it not go as fast. Everything that resists or opposes the flow of electrons. And it's measured with the SI unit of ohms. So if we summarize, current, simplified to, not V, I, and it's measured in amps. So this is going to be the SI unit. We also have potential difference. That's going to be V, and it's measured using volts, also V. And lastly, we've got resistance, the things blocking the movement of electrons. That's going to be R, and it's measured in ohms. If I summarize current is the flow of these electrons. Potential difference is the battery. It's going to be the battery, right? The battery. Let me draw the battery like this. And it's going to be the battery, the powering force pushing it away. And resistance is literally just the resistance in the path, blocking the path of these electrons. That's pretty much it. And thanks for watching.